Okay. Hey guys, welcome back. So in this lecture, we're going to be covering repeated substitution, which is a follow-up of the guess and check method, right? Okay. So just like we saw in the guess and check method, right? We were trying to convert a recurrence relation into a general form. I should say closed form, right? So guess and check was pretty much that you guess it, you see you solve it for a few first numbers. So let's say a1, a2, a3, a4, a5, and then you see the pattern, and then you try to find out what the closed form is, and you try to prove it using induction, right? This one is like way better. You don't have to do a lot of those things. It's just that you keep on repeatedly substituting, which I'll quickly show, and then you will pretty much see the pattern in itself in the equation, right? So it's going to be way easier to understand. So over here I have the steps. We start with the Tn. So Tn in this case is just T1 equal 1 and Tn equal to Tn minus 1. If you remember, this is actually the example from the last video that we covered. It's pretty much an equal to an minus 1 plus 1, right? It's actually the same example as the last video. So here's what we're going to try to do, right? We started with Tn. I'm just using this T form because it's just I'm gonna have to substitute, and it's gonna be like way better pretty much in terms of like drawing it on the board. Okay, substitute the recurrence for Tn minus 1. So here's what we're gonna do, right? We're gonna keep on replacing this Tn minus 1 with the substitution again, and we're gonna keep on doing this like once, like 2-3 times, right? Which will kind of give us a pattern that we will be able to see. Okay, so let's pretty much keep doing it again and again. So I start T of n equal to Tn minus 1 plus 1. Okay, now I'm going to substitute Tn minus 1, right? I'll just write down the formula on the side. So Tn minus 1 equal to Tn minus 2 plus 1. Right, this is going to be the formula. So you get equal to I should say 2 to Tn minus 2 plus 1 plus 1, which is you get 2 to the power of 2 Tn minus 2 plus 2 plus 1. Now, I want you guys to keep on following this equation that's happening on the board, right? So right now, all I did is, I hope you understand what, the step. Pretty much just replace Tn minus 1 with this equation over here, which is just like the previous term. So Tn minus 1's previous term would be 2 Tn minus 2 plus 1, right? So pretty much just replace it, and then since I had a 2 outside, I just multiplied it by 2 Tn minus 2, giving me 2 squared, and then plus 1 2, right? So 2 multiplied by 1 would give me plus 2, and then I already have this plus 1 at the end. So this is the final equation that I get. Now I'm going to replace this Tn minus 2 with the term again. So Tn minus 2 would be equal to 2 Tn minus 3 plus 1, right? I hope this makes sense. So you just get 2 square and then 2 Tn minus 3 plus 1 plus 2 plus 1. Now I'll try to explain why I'm not adding these numbers right now, but that will make sense pretty soon, right? Okay, so once again, I have 2 squared, and in the brackets I have this equation. I get 2 to the power of 3, because if you multiply this 2 squared by this term, right, this will give you 2 to the power of 3 multiplied by Tn minus 3 plus 4 plus 2 plus 1. Okay, so I can do one final step, and then I think it will make sense. If you do the next term, right, if you solve this one more time, you'll get 2 4 Tn minus 4 plus 8 plus 4 plus 2 plus 1. Okay, now I want you guys to try to pause the video and then understand what do you think this would be, right? Like kind of try to understand the pattern in this case. Okay guys, so now let's try to understand the pattern, right? So let's take a look at all the steps that we did. First step, first time I had the simple term, which is t1 equal 1. Second step, we replaced it, right? So we pretty much get 2 to the power of we get 2 to the power of 2 tn minus 2 plus 2 plus 1. When we did it once again, we get 2 to the power of 3 tn minus 3 plus 4 plus 2 plus 1. Now if you do it the fourth time, you'll get 2 to the power of 4 tn minus 4 plus 8 plus 4 plus 2 plus 1. I clearly see a pattern over here. And the pattern is that if I take a ith step, right? Now we're not considering, just wanted to clear one more thing, that this is after I've actually simplified it further, right? Because like I had 2 square, first I had this equation, but then I simplified it, I get this, right? Then I replace this term, tn minus 2 with this term, and then simplify it so I get 2 to the power of 3 and this term, right? But the point is that I see that every ith step, right? Let's look at the ith step. If you look at the ith step, let's just consider this term, right? Just this term for now. Look at all the terms for the steps that we are talking. In the second step, it was 2 to the power of 2 tn minus 2. Third step, it was this. Fourth step, it was this, right? So I see the pattern that it's pretty much that this part for the ith step would be 2I tn minus I. I'm just kind of ignore this part for now. Just try to understand and make sure that you understand this part, right? Like this makes sense. Okay, so once again, it's just pretty much that I see the pattern that for the ith step, this first part is pretty much 2I tn minus I, right? Okay, now let's look at the second part, which is the more interesting one. If you look at this, right, in the first step, I just had 1, which is like 2 to the power of 0. In the second step, so the first base case, you would have 1. In the second case, when you take a step, right, when you take the step in the next step, you get 2 plus 1 plus 2 plus 1. In the third step, I had plus 4 plus 2 plus 1. And in the fourth step, I had plus 8 plus 4 plus 2 plus 1. Now, I see the pattern in this case once again, right? Which is pretty much that this is 2 to the power of, these are like the powers of 2. So I pretty much see that this is going to be 2 to the power of something plus like 2 to the power of 3 plus 2 to the power of 2 plus 2 to the power of 1 plus 2 to the power of 0, right? I see a pattern like this happening over here. But I need to understand what the pattern would be in terms of the value I. Okay. And now let's see how do we understand the pattern in terms of I. I see for the base case, for the first step, it's 2, 0, right? If you're at step 1, it would be 2, 0. If you're at step 2, it would be 2 to the power of 1. I'm just going to write it down over here. For step 1, we had 2 to the power of 0. For step 2, we had 2 to the power of 1 plus 2 to the power of 0. I'm considering this part over here, right? Just this part of all the equations. So for step 1, we just had 2 to the power of 0. If we took a step again, we had 2 to the power of 1 plus 2 to the power of 0. For 3, 2 to the power of 2 plus 2 to the power of 1 plus 2 to the power of 0. And if you look at for 4, it was 2 to the power of 3 plus 2 plus 2 1 plus 2 0. The pattern is clear from this one, which is that this is pretty much 2 to the power of I minus 1 plus 2 to the power of I minus 2 plus ... we keep on going until the very end. Okay. Now once again, if you're not able to understand like how I did it, just pause the video or maybe take a step back and try to understand like what exactly I did. My point is simple, right? For a certain step, if we just talk about this term, right? For the first step, it was 2, 0. Second one, it was 2, 1 plus 2, 0. Third step, it was 2 to the power of 2 plus 2, 1 plus 2, 0. So I see the pattern that this is pretty much that for step I, it would be this term plus 2 to the power of I minus 1 plus 2 to the power I minus 2. It will keep on going until we reach the final value, which is going to be 1. Okay, now I hope it all makes sense until this point. Next important point to understand is we can't just leave it over here, right? Think about what can we do to replace so many pluses, right? We need to find out a way. And the formula that for this part would simply be the geometric series that we have already covered, right? So pretty much you get, I'll just kind of clean this part over here. So you get 2i t n minus I plus 2 to the power of I minus 1, 2 to the power of I minus 1, right? And this is going to be your final term for now. Okay, so once again, just try to pause the video, understand everything. If you don't know the geometric series, it's pretty much the formula that we have covered in one of the lectures. And I remember telling you guys that it's very important that if you just remember this formula, right? Just know it by heart. So this is what the formula would look like for it. And now we have done pretty much, we started with Tn, we substituted it for recurrence for Tn minus 1. We substituted it again and we did it like 2 more times, right? We spot the pattern and this is what the pattern we have spotted so far. But now we're going to do these steps, right? So let's start doing these steps. Okay, so once again, this is the final form, right? Now, this is the step we are at. Set I, so you hit the base case. Now, what I mean by this is, the base case was T1 equal 1. This is our base case. By hitting it, what I mean is that I need to keep on going back again and again, like taking a step back, keep on replacing this Tn minus I, like again and again, that you reach the final, the base step, right? Because this is recurrence, right? In recurrence, let's say you're supposed to find A1000. Now, the way you would find it is that you would start at A1000, you would replace it with equation for A999, keep on going until you reach the base step, and you would have a big equation, right? With the base value. So once again, that's exactly what we are trying to do. We're just trying to take a step back again and again in a general form, and then trying to reach the base case, which is T1. Okay, so how do I do it? In my equation, I see it is 2 to the power of I, Tn minus I plus 2i minus 1, right? Okay, my goal is to replace this value, Tn minus I, with T1. So for this step, wait. I'll just give it over here. Okay, so replace Tn minus I with 1. Sorry, I should say T1. How do I replace it? I would have to replace n minus I with 1. So you get n minus I. I would have to set n minus I equal 1. So you get n, I should say I equal n minus 1, right? Once again, I need to replace Tn minus I with T1, right? Which is the base case, which means that I just need to keep on taking a step back until I have the base case for which I have the value. So what I would do is, I would have to set n minus I equal to 1, or I can say like replace it with 1. So if I set n minus I equal 1, the value of I would have to set is going to be n minus 1. Why I'm trying to set it the value of I? Because in my equation, I see this value I, right? We need the equation in terms of n, right? But we have this extra term I, and that's exactly what we are trying to replace, right? So we set up I equal n minus 1. And now let's just solve it for this equation. So you get 2, you had 2i Tn minus I plus 2i minus 1. So if you solve this, you get 2n minus 1 T1 plus 2n minus 1 minus 1. Okay, this is what you get. If you try to solve it, now we already have the answer to t1, which is exactly 1. So you get 2n minus 1, 1 plus 2n minus 1 minus 1. You keep on solving it again. 2n minus 1 plus 2n minus 1 would be 2 times 2n minus 1 minus 1. 2 times 2n minus 1 would simply be 2n minus 1. And this would be the final answer, right? I know this is kind of like getting messy on the board, but I honestly tried my best. I had to erase it one time to kind of set it up once again. So this is my like third take for this lecture, to be honest. But it just, the board gets really messy. Okay, so, but the point is, I'll just give a quick summary. This is the final answer to this question. If you remember in the last lecture, we had the same final answer too. So repeated substitution is pretty much that you keep on substituting it again and again. And after some I steps, you see the pattern. The pattern in this case is pretty easy to understand, right? Once you find the pattern, you set I to hit the base case, right? Which is, you replace I in this case with the value, so you would have the base case. So in this case, we had to replace n minus I with 1. Remember, it's very important to understand, you're not replacing I with the value 1. You're replacing this n minus I term with t1. That's why I would have to set n minus I to 1, right? After replacing it, we find out the value for I, because that's what we are trying to replace, and we solve the equation and we get the answer in terms of n, I should say, right? Okay, so I hope you were able to understand this question. I'll give a bunch of practice questions now, and I think it will make a lot more sense. Okay guys, I've given these questions on the board. Try to solve them, pause the video, and then I'll solve the questions on the board. Okay, so I'm not going to solve this one. I hope like this is pretty much the basic one, but I'll solve the other three for you guys, right? So let's move on to the second question, right? Use guess and check to find the closed form for a1 equal 1, an equal an minus 1 plus 2n minus 1, right? Once again, if there's any issues that you guys think I need to solve, any kind of problems you guys face, let me know. Like just let me know in the comments, like anything, right? And I'll try to fix those or add those changes. Okay, so use guess and check to find the closed form. Once again, I'm just gonna solve for a few terms, right? a1 I've been given equal 1. Let's see what a2 would be. a2 would be an minus 1, which is a1 plus 2 minus 1, which is going to be 1 plus 4 minus 1, which is going to be 4. a3 is going to be a2 plus 2 times 3 minus 1, which is going to be 4 plus 6 minus 1, which is going to be 9. a4 is going to be a3 plus 2 4 minus 1, which is going to be 9 plus 8 minus 1, which will be 9 plus 8, which will be 16. Okay, so I think if you look at this, right, so I had 4, 9, 16. I think the pattern is clear, right? For a2, the answer was 4. For a3, it's 9. For a4, it's 16. So I think the pattern is an equal n squared. And this is going to be our closed form. Now, once again, I cannot conclude this. I would have to like unless it's been given in the question and like in real life, you would have to actually prove this by induction. But for this question, you don't have to do it, right? But I would say like for practice, you can try even doing the induction proof just for the sake of like getting more familiar and like having like more practice, I would say, right? So additional solve induction in like I should say provide proof. Okay, I hope you were able to understand this question. So guess and check to find the closed form. The closed form that we come for this question is going to be an equal n squared, right? Okay, third step, third question, it's going to be okay, so use repeated substitution to solve T1 solve the following equation, right? I'm just going to erase this one. Okay, so answer 3. First of all, T1 equal A, Tn equal Tn minus 1 plus C. Okay, so let's take a step now. First, we start with I have Tn equal Tn minus 1 plus C. If I substituted once, I would get T n minus 2 plus C plus C. Right? I hope you were able to understand this. In the first case, in the first iteration, you had Tn minus 1 plus C, right? I'm just going to make this board on the side. Tn minus 1 would be Tn minus 2 plus C. Tn minus 2 would be Tn minus 3 plus C, right? So in the second case, I have this. If I do this one more time, I get Tn minus 3 plus C plus C plus C. So now let's try to understand the general formula, right? For the first case, Tn minus 1 plus C. Second case, if I take one step again, we get Tn minus 2 plus, I can write this 2 plus C as plus 2C, right? And if I do it one more time, I get plus 3C. So for ith step, just try to guess it. It would simply be Tn minus I plus IC. Okay. Now, once again, we're still not done with the question. I need to replace this n minus I with the base case, right? The base value, which is T1 equal A. So I need to reach the base answer again. So what I'm going to do is, I'm going to set n minus I equal 1. This gives I equal n minus 1. So replacing I, we get T1 plus n minus 1 C equal A plus n minus 1 C. Okay, and that is going to be our final answer. Now, once again, this probably looks familiar. Like if you're watching the previous lectures, this might seem familiar because this is the arithmetic progression formula, right? We covered it in the last lecture. I just gave the question in terms of like I should say the recurrence form, and asked you guys to solve it pretty much. Okay, so I hope you were able to understand this question. Now let's move on to the final one, which is a population doubles. Just erase it first. Okay, so a population doubles every year, starting at 500. Find the recurrence form, right? Okay, this is like, let's just logically think of it, right? A population is starting at 500. Whenever you see the word starting in a question, right, it would pretty much mean that this is the base case. Like the first term, or I should say question answer 4, base is 500. Or I can say, or A1 equal 500. I hope this makes sense, right? Like I pretty much mean that, okay, I'm starting with 500, so my base case would be A1 equal 500, right? Okay. Population doubles every year and we need to find a recurrence relation for it. Once again, what is a recurrence relation? Every term is defined in terms of its previous term, right? And think about this. If I have A1 equal this, right? For some year AN, right? For some year AN, what do you think we should define it? How do you think we should define it in terms of its previous year, right? We've already been given in the question, a population doubles every year, right? It's doubling every year. So pretty much this is simply going to be 2 A n minus 1, and that's pretty much it. So what my final answer is going to be, I have a1 equal 500, an equal to an minus 1. I just want to confirm my answer is correct. Yeah. Okay. So that's pretty much it. And if you guys want, you can also like do another part for this question, which is, yeah, I would suggest trying to find the closed form for this question, but that's going to be like the additional one. So I'll just mention it. Okay, and that's pretty much it for this lecture. I know this was like a really tricky lecture. And I think the guess and check and both this one, repeated substitution, are very tricky lectures. So that's totally fine if you're not able to like, you're not able to fully grasp the content. I would say that just solve a few questions again and again. Maybe try to watch the lecture one or two, like maybe a few times. And then I think it will start making sense, definitely, right? But practice is super, super important. And I'll see you guys in the next video.